Hello everybody, and in this video, today we are going to be dealing with sine rule. So with the sine rule, if you're given a triangle, right, where in this case here, okay, we have angle A, angle B, and angle C. And once again, let us quickly just rewrite these sides, which would be small a, and then B would be opposite small b, and then C, angle C would be opposite small c with the sides, okay? Now this would be a case where you see all these angles are different. You would use the sine rule if the angle is not between the two known sides that you have, or you were given two angles and a side. Okay, so those are the uses for this sine rule. And the formula that you are given, there's two possible formula you can use. It's actually kind of the same. So I'll give you both of them. So it would look as follows, right? Because it's sine rule, we're going to be dealing with sine. I mean, like, why else would it be called the sine rule, right? So the first possible formula you could use is sine of angle A over the opposite side of that angle, which would be A, which is the same as sine of angle B over the opposite side, which is B, which is also equal to sine of angle C, which is over the opposite side of C, okay? The other possible formula you could use is going to be the other way around. So you could say the opposite side divided by sine of the opposite angle of that side, and then equal to B over sine of B, angle B, which is also equal to C over sine of angle C. So it actually doesn't matter whether you write them on the numerator or the denominator, whichever one you feel more comfortable with, go for it, man. So this will be your sine rule, okay? So usually you don't use all three of them at once. Obviously, when solving for the equation, usually what you would do is you would break it up. So you would maybe let these equal to each other to solve for variables, or maybe you'll let this equal to that to solve for certain variables. It really or you can even like let these be equal to solve for variables, but it really depends on the question. So let's get into the actual application of this sine rule and see how we're actually able to answer the question. So here's our first example. Solve for sides B and C from triangle ABC below, and we have the following triangle where we have ABC, we have sides 26, B and C, and we have angles 65 degrees, 67 degrees, and an unknown angle over here. Okay, so first things first, right? We can actually find this missing angle, because if we find that missing angle, it could be crucial to our actual answer, okay? So that angle we can actually find by using the sum of angles in a triangle. But for this example of the video, we will actually get the value of 48 degrees, okay? So it is found to be 48 degrees if you were to use that rule. But for now, we're more focused on sine rule, okay? Okay, now from here, what is our sine rule? It is basically just going to be the sine of our angle, which is going to be angle A. Let's start with angle A, okay? We're going to do angle A, then B, then C. We're going to first write down our three expression equation. So it'll be sine of 65 degrees divided by the opposite side, which is 26, okay? So remember, if you're going to take the side of an angle, you must divide it by the side that is opposite that. So 65 degrees, the opposite side is going to be 26, okay? Then this is the same as sine of the next one. Let's say for number B, angle B, it's going to be 48 degrees, and we're going to divide it by side B, which is called B, okay? And this is just going to be equal to sine of 67 degrees, which is represented by angle C, divided by side C, okay? C is opposite to angle C. Now, from here, what do you notice? This whole expression here is one value. There's no variables. However, this one and this one have variables, but they're all equal. So what we are going to do is we are going to let this be equal to this and solve for b. Then we're going to let this be equal to that and then solve for c. And then therefore we're done with the question. That's it. So all we need to know is the formula, and then we just need to solve, okay? So let's first solve for b, okay? So for number b, or sorry, for b over here, okay, we're gonna have sine of 65 over 26, which is equal to sine of 48 degrees over b. And then if we use cross multiplication, okay, so if we multiply across, then notice we are going to get 26 multiplied by sine of 48 degrees, which is equal to b multiplied by sine of 65 degrees. And if we're solving for b, we need to divide both sides by sine of 65 degrees. Therefore, b is just going to be equal to 26 sine of 48 degrees divided by sine of 65 degrees, okay? And then b is just going to be equal to, using our calculator, it's going to be approximately, so we must actually say approximately 21.32. And this is a side, so it's going to be units. Not units squared, remember, because if we're dealing with sides, it's going to be units, but if we're dealing with area, it's going to be units squared, okay? Okay, so now we dealt with the equating of the value and b, but now we're going to try and find c. So we're going to do the exact same thing, but this side is just going to be with the c, okay? So now this is what it's going to look like. It is going to be sine of 65 degrees over 26, which is equal to sine of 67 degrees divided by c. So now we want to solve for c, okay? And we're going to cross multiply, okay? We're going to cross multiply, and then what we're going to get is we are going to get c multiplied by sine of 65 degrees, which is equal to 26 multiplied by sine of 67 degrees, okay? And then from here, we can divide both sides by sine of 65, then c is on its own. Then we have 26 sine 67 degrees, all divided by sine of 65 degrees. Then we can plug this into our calculator. Then we should get an approximate value of 26.41 units. Okay, so now we found both b, so therefore we found c, and we also found b in this case. Here's example 2. We need to solve for the angle P in triangle PQR below. So we have angle R being 25 degrees, Q and P are unknown, and we have the sides 100 and 60, okay? So for this one, we can use sine rule because we have two sides and we have an angle that is not between those two sides, okay? Remember in the beginning when I said the uses for sine rule, okay? So let's just write this in the sine rule form, okay? So it'll be sine of 25 degrees, right? Let's start with R, divided by the opposite side, which is 60, okay? It'll be 60. This is equal to sine of, let's say, P, angle P, and the angle the side opposite angle P is just 100, okay? And this is equal to sine of angle Q, okay? Angle Q, what is the opposite side? Well, we don't know. Let's just call it RP, okay? Because that's the side's name, RP. Now, this one is totally useless because, like, what are we going to do there? But the whole question asks to solve for P, meaning we know that this whole thing is just one value, right? If you plug it into the calculator. But you can solve for P by equating these two together, okay? So therefore, what you can do is you can do the next step like this, and then you can say sine of 25 degrees over 60 is equal to sine of p over 100. Okay. And then from there, we can just solve for p. So we can cross multiply, then we're going to have 60 times sine of p, which is equal to 100 multiplied by sine of 25. Okay. And then we can divide, but we want to get sine of p on its own, so we divide both sides by 60. Then we have sine of p, which is equal to 100 sine of 25 divided by 60. Okay. And then in order to get p on its own, we need to take the sine over, meaning it's going to be arc sine. So what we're going to do is put it all in the calculator, and we're going to get the following. Or I guess we can first show what we're going to do. So it's going to be angle P is equal to arc sine of 100 sine 25 divided by 60. Okay. And then what is this going to give us? Well, if you say shift sine on your calculator, then you'll get the arc sine of whatever this is, and then you'll get an answer that's approximately going to be 44.78 degrees. Okay, so that is the units of angles, it's degrees. However, here's the thing, right? This is an ambiguous case. Why is that? Now, the thing is, we need to know that there's a potential obtuse angle that we can have as well in this instance, okay? It all goes in accordance to our trigonometric equations that we've already covered. So for this one over here, right, in order for us to convert this into an obtuse, because remember, we need two cases, okay? So the first one is an acute angle, and I've also covered this in the area rule. But then the other one, we need to be able to find the obtuse. So the other step is to find the obtuse. So the angle P could also be 180 degrees minus the angle that we found, which was 44.78 degrees. And this is just going to be equal to 135.22 degrees. Okay. And this is the case of the obtuse, because you can see now that this angle is above 90 degrees and below 180 degrees. And that is what we do, okay, in order to get the obtuse potential angle for this, okay. So it's actually, this is what we call an ambiguous case. So we want to find both cases of an acute angle as well as the obtuse angle.